In this video, we are given 3 points, and we're going to consider the triangle that has those 3 points as vertices, and we will learn how to find the angles in this triangle. So first, let's just draw a picture. So maybe let's call these points P, Q, and R. And we're looking at this triangle, and we want to find the 3 angles in it. So first, before we do anything, I want to just make up some notation. So I want to write these vectors that point from one vertex to the other and give them names. So here I'm going to call this guy V1. Let's call this side pointing from P to R V2. And the third side, let's orient it this way from Q to R. Let's call that V3. So I just want to write what these are first before we do anything. So V1, again, as you can see in the picture, is just the vector from P to Q. So if we want to write the components, we just subtract the components of Q minus the components of P. So we just get 3, 2, 4. Similarly, V2 from the picture points from P to R. So we subtract the coordinates of R minus the coordinates of P. So here we get -1, -2, 0. And lastly, V3 is the vector from Q to R. And its components will be those of R minus those of Q. So we get -4, -4, -4. And let's also, before we move on, write the lengths of these 3 vectors. So the lengths of the 3 sides of the triangle. So here, V1 we can see has length square root of 29. The length of V2 is square root of 5. And the length of V3 is square root of 48. Okay, so why did I do this? Why did I write all this out? Well, the key here is to use the formula that relates the angle between 2 vectors, which I'll call theta, with the dot product and the lengths of these vectors. So remember, the formula goes like this. If I have vectors v and w, and theta is the angle between them, the cosine of this angle is given by the dot product of v and w over the product of their lengths. So the idea here will be to get each of the 3 angles in the triangle. I'll use this formula. And these things on the right hand side of the formula involve the lengths, so that's why I wrote this stuff above. So okay. First, let's do the angle at P, which I'll call theta sub P, meaning this angle between the vectors V1 and V2. So I want to use my formula, so solve it for theta, so just take inverse cosine. And for v and w, again, we'll use V1 and V2 for the angle at P. So on top we have the dot product, which you can see is -7. And then divided by the product of their lengths, so the length of V1 times the length of V2, so square root of 5 times square root of 29. And this doesn't look like it comes out to anything nice. It's not like pi over 2 or pi over 3 or something, so we'll just leave it like this. And then we just use the same formula for the other 2 angles. So now if we want the angle at Q, which I'll call theta Q, this is the angle between the vectors minus V1 and V3. Because you see V1 points in the wrong direction. So we want to take the dot product of minus V1 and V3, which we can see from up here is going to give us 36. And then let's see, V1 and V3. The lengths are square root of 29 and square root of 48. And lastly, we can do this for R. So theta R, the angle at the point R, so this is the angle between the vectors minus V2 and minus V3. So we use the same formula. The dot product of minus V2 and minus V3 is 12. And the product of the lengths, length of V2 times length of V3, is square root of 5 and square root of 48. And so that's it. We have found the three angles in this triangle.